Hello and welcome to our next workflow demonstration. So the scan data we're looking at right now, it's a pretty common case. It's a worn and broken part. So if we are looking from the profile, we can see it's already twisted and it has some, I guess, more or less worn out parts of this. We don't have too much information about this part, but in general, this is quite typical part for reverse engineering tasks. So we have to repair something and replace some worn or broken parts. In this case, we have to consider many things. So if this is a warped part, we have to find one exact location that we're going to work on to keep consistency of all parts around. It means if we decide to count as, for example, this region, the lowest part of this warping as a standard part, and this part is a defective part, it means we are going to extract most of our mesh sketches exactly this direction, and most likely we're going to use exactly only this blade or everything that is really close to the region that we consider as a good one. So as the first thing, as always, we're going to align our scan data to coordinate system, and in this case we have to define actually really good axis for this, since it's a revolved part, circular part, and we're going to use circular pattern to pattern all these blades. So we need to find a really good axis for the center of this part. So let's try to extract some primitives right now. I guess I'm going to start with probably plane here. Okay, and let's see, what do we have here more? Okay, let's try to use this seat as a cylinder, perpendicular to plane 1. Let's create this and let's hide the plane. As a test, we can just create revolve sketch, for example. Let's say fit some line here. Probably we can fit another line here. And I guess I will fit another line here, just to see how it goes. Click revolve and see our results. Here we can see that it's not really great. Seems we are a bit off the center. Let's get rid of this revolve sketch, and we can actually try to find center. Maybe this way. So let's create another cross-section sketch, and let's fit go here. Actually, I think this approach will work quite well in this case. So yes, we can see that we are pretty good with our outline of our part. Click OK. So I'm going to use this as our reference. Let's hide this for now. Basically, I have this extruded part, which will be served as a axis for center of my part. I have this plane, and as the next step, I want to find something what I will be using as a good quality part here, good quality region. So as I said previously, I guess I'm going to use the bottom part of this warping here, and how could I do that? So probably I'll just drag sketch somewhere up. So something like this. Create sketch. Hide our extruded part so I can see the center of it. Just drag one line, something like this. Okay, so actually now I can make it a smaller part. For better visibility. And right now I'm going to align this candidate to coordinate system. As a primary feature, I'm going to use my plane. Plane is a primary. As we can see, the Z direction is opposite right now, so let's flip it. As a secondary, I'm going to use our extrude, and the third one will be this line. Okay, so let's see how it goes. Okay, looks pretty good, so we can now close this dialog window. Hide this sketch. We can hide this plane. Okay, good. So from this, we can start to actually build our part. So for easier handling of this project, I'm going to split this part in 3 sections, in 3 parts. So one would be this top side of this impeller, another one would be bottom side, and the third one would be these blades. Let's start with simple revolved sketch. In this case, let's see, where do I have better geometries? Yes, I guess I'm going to use exactly this location for cross-section plane. Geometry here looks decent enough. Only downside is we have here this where of this part. So maybe should consider to use this side. For all our revolved sketches. So let's say this is going to be 90 degrees from initial plane. And let's hit create and start with, actually not like this. Let's get rid of this first sketch. Let's create another one. Revolved rotation 90 degrees. And let's see what we will got as an outline mesh result here. Okay, so we have result of our outline. Let's try to fit some entities and do a revolve and see how it goes. So basically, we can see that our part isn't very consistent cylindrical object. It's not actually round, so it means it's like more or less egg-shaped. Diameter is changing and surface heights are changing. If we use clip, we can see that in this exact location we are getting these cross-section points. So let's mostly try to use most of them. Here I'm going just to eyeball this one right now. Let's connect them. This way, let's roll and see our result. So as you can see, this revolve is a bit far from being perfect. Since we used one exact location for our cross section, we want to use this all the time, so our part dimensions doesn't change and some location of features doesn't change. Basically, we have to consider something that we can sacrifice in case if we want to actually reverse engineer twisted parts. So it's not just about creating some features and randomly everywhere. So you have to consider how this part was built and how it should work, and just try to minimize locations where you are working on this part. So if you start at, for example, we set up our first cross-section sketch at 90 degrees, then try to use everything that is close to this region. In that case, you will get pretty close to initial part as it should be when it was created. So okay, as we see, this one was pretty good, so we can go and edit our sketch to add some thickness. What we can do, we can try to select all these entities, click on offset. See how it goes. Okay, probably I'm not actually satisfied with the result, so let's make this manually again. I will start by fitting here an arc, line at the end of arc, and I'm going to align this line, let's say here, extend this, fit another line here, and at this point I'm not completely satisfied as well, so let's get rid of that line. Let's fit somewhere here. Let's try to add tangent arc. Okay, this looks like more or less a decent result already. Let's say this should be purely vertical. Extend this. Actually, since we have this sort of transition here, let's actually create one. Basically, these mesh sketch slice points we see here, so this is like a maximum and this is minimum value, so we can aim to something close to middle of it to get an average. So let's do it this way. Actually, before we're doing that, let's get rid of this line so it doesn't mess up all our sketch. Let's make it like this. And like this. And intersect them. So here again we have the top part of our twisted edge and the bottom part. Actually, in this case, currently this doesn't matter because we have quite nice tools to move faces, so we can later adapt all of this. Okay, so we have this solid here. Let's see the deviation analysis. Okay, this looks fairly good. Let's see, so this is the location where we started, and we can see the bottom side here. We are quite far away. So let's go back to our sketch and reposition this line, and let's try to connect them with tangent arc. So like this. Okay. Now we see we're close on this side, close on this side. It's quite difficult to judge something about this region because scan data initially isn't that great. We have quite a lot of noise here. So I'm going to assume this is good enough for now. Close it, hide the sketch, and at this moment we can come over here actually and hide our sketch so we know the correct position. So move face command. Select face you want to move. I'm going to use offset option. And here by dragging slider you can reposition, you can move your face until we hit the good result. So I'm going to leave it right now exactly like this. You can take a look in general. Deviation analysis, we're like super close to this part. This outside I left extended with purpose. So I'm going to recreate all the elements extended and later just trim all this outer boundary. Okay, so we can hide now this. Let's hide our first solid. Let's create something here on the bottom side. So probably we can try to use maybe another option, but let's duplicate this sketch. Get rid of all this. Let's see what do we have here. So we have, I would say, pretty clean lines, extracted from our scan data. So let's try to fit some entities here. Let's intersect them. Okay, so in this case we can see this doesn't fit, so I'm going to use freeform curve here, here, here. Okay, set this to tangent, this connection to tangent. Here I'm just going to position this point. Raise this line a bit. Let's create revolve and see results here. Okay, I think I'm pretty satisfied with this. Let's create all the rest. Lines in this case, but probably I'm going to create another cross-section sketch here without outline option because I'm going just to use entities exactly where we have this plane. So like this, so we have a much cleaner result here. And we can use our tools for quick fitting of entities. Let's see, we have some indented part here. Let's fit an arc here. Like this. Here also I need some sort of, let's say, an arc. And we can come over here to set straight sections, intersect, fillet. Maybe I'm going just to create like a complete geometry, actually probably for all of this part. So this entity most likely should be vertical, definitely not tapered to the downside, considering this is a shaft mount. The shaft comes from the backside. This should be as minimum vertical. Actually, in this case, we're using entities right here, so it's tapered to the outside. Let's use it in the same way. Like this, and just punch it through our previous revolve. Let's intersect these two. So create another revolve. See how it looks on the bottom side. Looks quite decent. Okay, let's hide our sketch. Let's hide the scan data. Trim these two revolves together, so we get our second solid body. Like this. We have this one, so the last part that we need, we have to create our blades. So in order to recreate our blades, we have several options here. One option is we can unroll our scan data. Let's see how it goes. To unroll our scan data, we need cylinder. So since our part is aligned to coordinate system, we can just tap here to create the cylinder. Let's use diameter, something like this, because diameter of this cylinder is sort of neutral plane which will be used for unrolling of our scan data. I'm going to create it like this, and we can go to our scan data tab, unroll feature. It asks for pick a cylinder. Pick our cylinder, and here we have to figure out where is the starting point. I will show our sketch, and as I said, I'm going to use all features close to this initial mesh slice plane. So it means I'm going to use exactly this blade for reconstruction. So starting point here should work good for me. So click on preview. Here we have preview of our unrolled scan data. And this looks good enough for me. Yes, let's accept this so we can hide our previous sketches, scan data, and now wait a second. Previous sketch. Okay, so in this case I have cut away some information from the blade I wanted to use. So I'm going to delete all of this and unrolled scan data. Back our cylinder and repeat this operation. Probably I'm going to use it in this position. So I want to make sure this blade is complete here. Let's pull it a little back. And tiny bit more like this. Okay, perfect. Again, hide everything. And this is blade I want to use, so now I'm going to scan, reverse selection. Now I'm going just to hide all scan data that I don't need. So it's much easier for you to operate. Yes. Okay, looks good. So here we can see that from one side this blade is scanned pretty okay. We have most of the geometry. And on this side it's not that perfect, so it wasn't scanned completely here and all across this region, and later it got filled in your scanning software. Well, in most cases when I am scanning something, I'm disabling this option to fill holes. Sometimes it's much easier when here is just a hole instead of some sort of free-form filled mesh. But since we have this side pretty okay shape, we're going to use this one. And later just thicken this blade, and hopefully it's uniform thickness. It will work good for us. In other cases, if you see that blade thickness isn't uniform, you should consider some approaches. How could you get the best of your scanner and get most of geometry captured? Otherwise it would be like super complicated to recreate this. So now I'm going to fit some 3D curves here. I want to have actually 2 3D curves. As feature lines for this blade. Here you can enable curvature mode, so you can actually see where some fillet starts and avoid these regions for fitting your curves. Let's try with something like this. Probably I want to add some more points to our curve like this. Now we can see the deviation curve to the scan data. Let's see, in most cases it's green, means it's within tolerance of 0.1 millimeter, so it should be good enough. Let's enable back curvature shader and create another curve on this side. This. Let's position this point and this point slightly. Okay, so we have created these 2 curves. Come over here and click right mouse button, say roll sketch, tolerance 0.1. Okay, and here we can see our sketches rolled back to our initial scan data. Now I can just hide rolled scan data, come over here. So what I want to do here, I need like 2 extra curves to complete boundary of this surface. I'm going again to 3D sketch. This time I don't need curvature. Actually, maybe I do. Let's see how it looks like here. So I'm just going to connect these two. Here you can actually see that we have some slight bump on this side. And this is again something that you have to consider. Should it be there or not? Because it looks like geometry of this blade is sort of here flatter, and here we have some tiny bump, which probably we can ignore right now. And let's create another curve on this side. I'm trying to use least as possible amount of curve points to have consistency of this curve, so it's super smooth without any jumps or something, so it's like nice, straight and smooth. Okay, so we have this complete boundary right now. After this we can go to our fill surface tool. Select all 4 curves. Say on scan data. See analysis. Okay, up to me it looks nice and promising, so I'm going just to accept this. Essentially what I need to do right now is to extend the surface. Extend in this direction. So in this direction. Here, so we want to make sure it intersects completely with our top and bottom solids. Okay, that's good. And now I'm going to thicken this blade. Let's see, the direction is good. Let's enable deviation analysis. So average best looks like 1.8 millimeter thickness. And I'm going to accept that. So we have our first blade done. Nearly done. So we have main geometry. Now we have to actually cut it to have this face right here, and in order to do that I'm going to create another 3D sketch. The Couture shader won't help us this way, so I'm going just to slightly eyeball this. And I'm going to construct plane along this path. So this plane is always perpendicular to path, and I can choose some nicer region where I can see more or less flat surface. Case we don't have too much of this, but let's try just here. So considering most of scanners can't actually capture very well the super sharp corners, I'm going to line approximately like this. Okay, so this line is going to define profile for sweep here. This you can expand it. Let's see comparison. It doesn't seem to be super great in this region, so we can come over and edit our guide curve. Still not the greatest shape, but well, here we have to consider we want to create this as a line, like nice and smooth line, nice and smooth surface, or we want to introduce a couple more points to actually flex it. But in this case, I'm going to stay at this result, so I can unhide right now our blade, trim it this way. Okay. So it looks like really nice geometry. And as a next step, I would like to circular pattern it. Okay, so we have 7 blades here. Accept this. Okay, so here you can see that actually we have extended it a little bit too much in top direction. So we can come over and edit this, make it a little bit smaller and probably just a tiny bit more, just to avoid these poking out geometries. Okay, let's hide, scan data, and unhide our solids. Okay, so this looks like a quite decent result. So what I'm going to do now, I'm just going to merge all this together. So it's a one solid. This and let's just extend again our extrude. And we can just duplicate this face. Use this surface to trim away excessive geometry of our solid part. Okay, so this is something what we end up with. Let's see, general deviation analysis. And let's unhide some sketches that we used for initial creation of our features here. Verify that we are satisfied with result in this region of our scan data. I guess I'm going to leave this as it is right now. So basically, again, this is something what you have to consider. How good is good in what cases? So actually, probably you have to speak with your customers. So what are dimensional accuracy somewhere? Probably they can provide you dimensions of like diameters of this part or something like that, probably height or just whatever, something that they can provide you, what you can rely on. In this case, we have unknown object, which is twisted with some damages, and we have to figure out how to recreate this part. So this is like result what I assume to be good enough. Of course, if you recreate this part, probably you want to 3D print this to verify design. Does it fit with some decent tolerances to housing of this pump or fan or whatever this is? So this is purely up to you guys. So yes, hopefully this was useful workflow demo for you, and see you next time.